At first we are going to have refraction. It's the case of seeing some object from denser medium. So it means shift should be in that direction. So how much is going to be the shift, that you can find out. Here mu1 means the side where object is placed. And t is this distance. So to an observer inside the glass, 7.5 centimeter will be the image distance. 7.5. This thickness is 2.5. This mirror will think that the object is here. So how far from the mirror? 2.5 plus 7.5, 10. So the mirror will make its image 10 centimeter on the other side. Let's say here. So that should be 10. Final image we want. Now, this image will act, viewer is here, that has been assumed. So this image will act as an object for a viewer who is in the rarer medium now, denser to rarer. And from this, the distance is 12.5. So one more shift. Shift this time will be 1 minus mu2 by mu1. Object now is in this side. Mu1 is object side always. So it will be now 1.5 here. Viewer is in the other side. So mu2 should be 1. And what is t? T is the common boundary. Distance from the common boundary is T. That should be 12.5. Now when I say distance from the common boundary, I hope that private message is answered. Why should it be 5 in this first case? In the first case, you are watching from here. So the interface is this. From the interface, object distance is 5. Can you calculate that? This is for observer here, so it should be up. This shift should be up. That I am getting as 4.17. So for some observer who is here, from unsilvered face, you can tell the distance easily, here to here. Yes, D for delta is the answer I have. This was a very conceptual question. If you have questions regarding any step, let me know. Make sure you have understood it completely. Try this. If you want to use the board for drawing purpose, you may feel free to do so. That quick, how did you do it so fast? Question is about diameter. I'm just taking some straight line segment which can represent the diameter. If you dip your hand inside water, does it look bigger? So how can it be C? all that happens is the shift. We are talking about viewing directly from above. Axial type of situation. Yes, mirror. So lateral shift is not there. Lateral shift is not there. Vertical shift is there, but not lateral. Any questions? Let me know. Answer is A. What you see is a glass slab, and one side of the glass slab is silvered. Consider some light ray incident at 45 degrees angle. Mu is given, and the question is about deviation. What we mean by deviation? Final ray or emerging ray and incident ray, angle between them is called that angle of deviation, and that's exactly what is asked. And this side is air. This is air. This is air. How can you say it is refracted ray? That is regarding the private message. Why is all this information given that this is silvered? Okay, first you try it, then I will discuss. No, not just after it hits the silver. It is eventually what happens. That is called emerging ray, eventual ray. Not just after it hits the silver thing. Let's see. Optically rarer to optically denser medium. How much are you getting this angle as? If you did not get that angle, then how are you getting the final answer? Okay. By using principle of reversibility of rays, let me see if that approach works. So let's say I do not find this angle, but I know from reversibility principle that these must be equal, and also that these must be equal. Well, 90 degrees. So how are you getting 45? Actually, the value of mu is not even required. We can do this problem from the argument of symmetry based on principle of reversibility of rays. So, if this angle is 45 and that angle is also 45, angle between the incident and emergent rays has to be 90. That is called the angle of deviation. Strictly speaking, not this, strictly speaking. It should be like the way you find angle between two vectors. Strictly speaking, it is this angle. The angle between this direction and this direction, 90. Any questions? If you have, then let me know. If mu is changing, then bending would be different. So C and D are not possible. Inside the liquid, bending will take place. because mu is changing. Inside the liquid, bending should take place. Straight line, this means that no bending in this part. How can that happen? C and D are not correct. Let's focus on A, D. Now, the bottom has greater refractive index. So, as mu increases, the tangent, if you take several tangents, if you draw, then those tangents are showing inward characteristic. This is looking okay. This direction mu is falling, and if mu falls, then how can bending be like that? It should be having opposite behavior, bending away behavior as mu less side is followed. It should have been something like this. A is correct. Any questions? If you have, let me know. You have water also, you have slab also. This is water, this is slab. Slab is dipped in water. Object is here. Some distances are given. This is 9. And the question is, The distance between two images when seen from the other side of the slab is 4 centimeter, 2 centimeter, 6 centimeter. Only one image is formed. Perhaps some more clarity is required in the location of the object. Imagine object to be small but still half inside. So maybe I can show it a little bigger. So maybe you can imagine 1 millimeter long something, half of which is inside water and half of which is above water. That type of thing. Okay, I'm showing intentionally somewhat bigger. Now think about it. Okay, maybe I can do one theory for you that will make it easier. We have discussed the shift case for one particular situation. We can do one more shift case for a situation like this. When you have something on the other side, this is a slab, and we are watching from here. Now what is the formula for shift? Actually you could derive it on your own, but anyway I will discuss it. So the formula for shift in this case, what happens? First, you place yourself inside this. So optically rarer, optically denser. That means this O will look somewhere here. Say I dash. And this shift OI dash is given by how much? 1 minus. I will have to give some names. This is A. Thickness T I can use. This is B. So 1 minus 1 by mu into how much? OA. Right? Now this I dash is seen from here inside. This will act as object for this interface. So you have one more shift. And this time you are watching from here, final fellow, that is denser to rarer rays coming in. So it should become now denser to rarer, closer. So maybe final I is here, or it could be here. So this shift, which is I dash acts as object for this interface. So this shift is, I am talking about just actual positive distances, no negative thing either here or here. Now interface to object distance, object is I dash, it should be B I dash. So B I dash. We are interested in the eventual shift. Eventual shift is IO. Eventual shift is IO. So clearly the fraction and I think II dash should be bigger than OI dash. So II should show somewhere here. That should be more accurate. So final shift, II dash minus OI dash. This is common. BI dash minus OA. BI dash This is how the actual ray will travel. First bend in, then out. Okay, this was 1 minus mu2 by mu1. Object size is mu1. And in the second case, object is actually I dash, and rays are coming from within this. So mu1 is mu. Mu2 is 1. This is okay. That means mu minus 1 upon mu bi dash. Can you tell me what is mu times OA? What is mu times OA? Real depth by apparent depth formula. Real depth by apparent depth formula. Well, isn't it apparent depth? First diffraction. Apply real depth by apparent depth formula for first diffraction. This one. OA, I dash A. OA is real, I dash A is apparent. Now BI dash minus AI dash, that is C. That's the standard result. So interestingly, location of the object does not matter. This is the fixed result for shift in such situation. Any questions? Let me know regarding this. So now you can make use of that. And this will now be your assignment question. Detailed working is optional. We stop now.